Dear colleagues, thank you for joining me with this presentation. And today I would like to share with you our recent progress on auto detection of marine mammals from drone photos based on deep learning. The use of drone in marine mammal research has been increasing over the decades. Drones become cheaper with higher performances as well. Population survey is an important part in marine mammal research, and the drones have made this easier. If we look into the differences between the traditional boat-based survey and drone surveys, the drone survey they need less person involved, sometimes down to one operator. And it presents minimal disturbance to your target animals and of course costs less than boats. And there are indeed limitations. For example, mostly we only get photo and videos with drone surveys, and the view angle, unlike the panorama view on boats, we only get a limited angle based on the lens parameter of the cameras. And here is the general workflow of survey with drones. So first, you design your transects. You need to decide on the dates, coverage, takeoff landing site, altitude, speed, and camera settings. After this, you need to get your permit before the flight. You need to decide if the weather is okay, and then is the operation itself. After the flight, you have your aerial photos. You need to back up, and then is processing, examination, and data extraction. And that's the main part before we go to data analysis. And for examination and data extraction of aerial photos, I am going to show you one example of our case study. So here we were looking for East Asian finless porpoise. The area we are covering is around 30 times 25 kilometers. And the flight altitude is 200 meters. And for every flight, we cover 15 square kilometers. And for every flight, we have between 500 and 700 photos. And in total, for this small project, we get over 13,000 photos. And to look into one photo is like this. So we have this one photo, and here this boat is around 40 meters long. And here you look for the whole photo. You look for your target animal. Here, the finless porpoises. And you found them, and you mark them as one of your photos that has your target animal. And this is one photo. Now time this times 13,000 for this project. So it's extremely time consuming and visually stressful if you manually review all these photos. So naturally we want to find a way to help, and that's why we got the idea of using AI to help us auto detect. The technology of image recognition is now widely used in daily life. Your cell phones and public security systems keeps recognizing everything. And these technology have been used in marine mammal research. For example, NOAA Fisheries, they started serious competitions to detect and recognize individual right whales in photos. And a while ago, automated image recognition reduces human errors, but is challenging due to two reasons. One is the complexity of these images, and the animal's size, color, and shape will change depending on its position in water. So this poses some difficulties in using this method to find marine mammals. But later we have a machine learning system for automated detection with improved recall and precision rates. And for this study, we aim to achieve auto detection of target animals visible on our aerial photos, and we also want to measurement of body length in these animals. So the process outline is first model training. That includes training dataset input and feature extraction. After that is the model prediction part, including feature matching and target recall. And finally, data process. In this part, we deal with size measurement and data output. So first, we prepare the training dataset. So in this part, we manually find all the photos that have our target animals in them and to use. So all these photos, they are different in lighting conditions, in sea states, watercolors, and sun glitters. So this provides opportunities for the system to understand the differences of these parameters. And then the training and prediction using deep convolution neural network. This deep convolution neural network consists of many neural network layers, and two different layers, convolutional and pooling, are typically altered. So in this process, an image is subsampled multiple times. In this process, also being filtered. And for this model, we used ResNet, which has a function called the skip connections. These connections between layers, they add the output from previous layers to the output of stacked layers. So this results in the ability to train much deeper networks than what was previously possible. So the training process, it generates a JSON file that maps the object types in image dataset and creates lots of models. And then it picks the model with the highest accuracy and perform custom image prediction using the model and the JSON file generated. And hence, we have our results. And after that, we also do the size measurement using the photos that got picked out. And so in this formula, all the parameters are known for a certain camera with a certain model. And only one thing that need to know is h, height or altitude where the photo was taken. So that depends on the setting of your flight. With all these parameters, we get to know the meters per pixel, MPP. So when we have this value, we can calculate any distance or any distance on the map based on how many pixels it is. and then we have the body length or any measurements you want. And we also made a very simple GUI to help us finish this task. And now you see, we also show here, there are correct match on the left and the false matches, meaning some waves and sun glitters that are recognized as our target animal. And in the result, it shows the location of the animal and the estimated size of the animal. And in this process, the processing time reached 2 seconds per photo. So every photo we need only 2 seconds to find it, comparing to maybe a minute for manual review. And the accuracy reached 85%. In the future, we need to do some modification to the training model. And also we are going to need a larger dataset to get better training results. And also for the size measurement, further develop method need to determine we need to further develop our method to determine the upright position for animals. For example, some animals, they might be curved in the pictures. And that's all. Thank you for your attention. And if you have some questions or comments, please direct them to me. Thank you.